Let me walk through, this is the last minute worksheet part 2 for the AP exam review. So this is number 2 here. Given the differential equation, we have dg dt defined here for t is greater than or equal to 0. The point g of 1 is equal to 3.5 satisfies the solution for the differential equation. Part A says, write an equation for the tangent line of g at t equals 1. So we need a couple information to get tangent line equation. We need to find the order pair, and we need to find slope. The nice thing is the order pair is given to us. So there's our order pair. To find the slope, we're going to use this is our derivative equation. So I can take 1 and plug in for t, but there's no t value here, so I can just take my order pair. In this case, I'll take my g value, put it in for g here, and that will help me to move towards my slope value. So if I plug 3.5 in for g, 2 times 3.5 is 7, 7 plus 1 is 8, and then we have cube root of, or 8 to the 2/3. We can do this in our calculator, or we can do this by hand. Think of this as the cube root of 8. Do the cube root first, makes it 2. 2 squared is 4. 4 times 6 is 24. So there's our slope. We can put into point slope form. Y minus y1 equals m times x minus x1. But I'm going to adapt this just for the variables for this problem, which are in terms of t and g. So t, we treat it the same way like we would x, and g, we treat it the same way that we would y, being the dependent variable. So we have our order pair, 1 and 3.5, that goes in for t and for g. And then the m, the slope, plugs in for my slope portion, my slope value here. And then I can just solve for g. So add 35 to both sides. Sorry, add 3.5 to both sides. So 24 times t minus 1 plus 3.5. Part B, use the equation that we wrote in part A to approximate g of 0.9. So this is the linear approximation here. This is where we take our tangent line and we just plug that decimal value in. So take that 0.9, put it in for the t, and the numeric answer there is our approximation. Part C, use separation of variables to find an expression for g of t. So we're going to solve for g, but we're going to cross multiply, separate the variables. G's on the left, t's on the right. Okay, so here's my differential equation where this is what's given to us. So first thing I did, multiply both sides by dt. Now everything is up in the numerator location. We're going to divide the parentheses over. So once we divide it over, now we have full separation. We have the dependent variable information on the left and everything else on the right. So t, any coefficient, I want to go ahead and leave that on the right side. If you want, you can go ahead and move the parentheses up to the numerator because you know it's going to have to be there. I think for me, I just decided that I was going to just leave it down in the denominator and then move it up later. Either way, this parentheses has to move up eventually when we get it ready for use substitution, when we get it ready for antiderivative step. But I just chose here just to leave it in the denominator for now. So I let my u value be what's inside the parentheses, the 1 plus 2g. The derivative is 2. We solve for dg, which is du over 2. Use substitution, we get all these pieces to be in terms of u. So we have du over u to the 2/3. Bring that u up to the top. We have u to the negative 2/3. So now both sides are ready for power rule. So this becomes u to the 1/3 over 1/3 with a 1/2 sticking out in front. 6 becomes 6t. A plus c shows up. I'm going to clean this up here. So if I flip that 1/3, that becomes 3 times 1/2, which is 3 halves. Replace the u back in terms of g. And now I'm going to find c. So by plugging in my order pair that's provided for us at the beginning. All right, this order pair, 1, 3.5, 1 in for t, 3.5 in for g. All right, so when we do that, we can work our way down towards our value that we can solve for c. So 2 times 3.5 is 7, 7 plus 1 is 8. And cube root of 8 is 2. Cancel that out. And we get 3 equals negative we get 3 equals 6 plus c. We solve for c. C equals negative 3. We go ahead and replace the c value back in terms of our value that we just found. And now it's just a bunch of algebraic steps trying to get that g by itself. So here, once I plug that c with negative 3, I'm going to try to get g by itself. So I got to move this 3 halves over. I got to cube both sides, subtract, divide. So a lot of just algebraic steps. So here, multiply everything through by 2/3, or both sides by 2/3. That's going to clean up that left side. And then once I'm down to parentheses to the 1/3, I can cube both sides. Once I cube both sides, this 1 plus 2g is now free for me to move those terms. So subtract 1, divide by 2. Any form is fine. I'm going to leave it in this form, this g of t. So now part D says use the expression that we found from part C and then find g of 0.9. So 0.9, we just plug 0.9 in for the t and then get it down to a numeric answer. We have our calculator, we can plug this in, or we can leave it in this form. This form is fine as well. Once you're down to equivalence of the actual answer, you don't have to reduce and simplify. But if you have a calculator, maybe you want to, but either form is fine.